Hello, welcome to Coding with Indy. In this video, I'm going to show you how to create this timeline chart that you can scroll horizontally and has scroll physics. I created this widget for one of my apps to show daily events. As you can see, each day has a rectangular area, few pixels wide. The date is printed at the bottom with just the date of the month, and then on the start of every week, it prints the full date. If you look carefully, you can see the weekend, Saturday and Sunday, is shaded so you can have some orientation on where you are in the timeline. Okay, enough chit chat, let's get to the code. Let's first design the data structures for this. We want to plot multiple time series, and we should have a container class for that with a start date and a finish date and a list of time series objects. So time series or time serii class achieves that. You have a start date, you have a finish date, and then a list of time series. Now let's take a look at what time series object looks like. It should have a name, so that we can have some sort of a name in there. It should also have a color, so we can distinguish between various events when we draw them. It would also have a minimum value and a maximum value. This would be computed when you add events to this series. And then obviously a list of timeline events. And then let's take a look at what timeline event data structure looks like. It's a simple class with a value. In this case, we would consider them as double. It could be int. But it should be a number, some sort of a number. And we have a date, because it's a time series event, it should have a date. So now we have these data structures all defined. We can go ahead and generate data or mock data so that we can draw something on the screen. So that happens in generate mock data function. So it has we're gonna generate three time series. So I've given them blue, red, and green, and we're gonna generate for a total of 60 days, starting from today, going back 60 days. So we can use dot list generate function for this, which generates objects or elements for that list of a given length, and also it gives a lambda that would be used to generate that object. So we are doing some nested generations over here because we want to generate number of time series. So this would be 3, and also we want to generate events for each of those time series. So the first thing, let's take a look at how we generate a time series. Each time series will have a name, as we saw in the description or the definition of the time series: name, color, and so on. So we have a name, a color, and then a list of events. So in order to get the events, what we do is we again call list generate. We're gonna generate roughly 2 events per day, and then each date we will have a value between generated value would be between 0 and 100, and we would place this event randomly in the last 60 days, but we give it our 1 hour resolution. So this is what happens here. So it's to start from start date and adding a random value, random duration in the next 60 days, but with a our resolution. Once we do that, we will have the serii. It's called serii because it's Latin. I don't know, maybe it is. So, and then we need to go and sort this, because since this is random, it wouldn't be generated in sequence. So it could be 50 now, and then the next value could be 15. So we will, for each of the series inside the serii, we would sort according to the date, so they are nicely in a timeline, and then we set the minimum and maximum value. So here it's easy for us to do it, because these are we generate them between 0 and 100, but in reality this would be different depending on what sort of data that you have. You would compute this when you add values. Great. So once we have all that, you create the time serii class or object with the start date, finish date, and the serii, and then return it from this function, generate mock data. In this example, I generate the mock data right in the main function and then pass it all along. But it could be generated, I mean, the data could be loaded from anywhere. For example, in a real application, it would be loaded when the user log in, and then modified when the user adds or deletes some events. So we have a simple material app. We have this widget called timeline chart, which encapsulates all the interaction as well as drawing. We also put clip R rect so that you have nice rounded borders, rounded corners, and also this prevents the canvas drawing from spilling out of the widget. Okay, so let's go into the timeline chart and take a look what's in there. We looked at these things, right? So the timeline chart is a stateful widget because we want to have we want to store some state inside it. We will come to these bits when we discuss about the interactions, but for now it is wrapped inside a gesture detector because we want to handle the horizontal drag up data and horizontal drag end. We'll come to this later on, but essentially it's a custom paint object with a chart painter. This is where the canvas is, and we pass in the generated data in the serii object and a variable called pixels per day. So usually when we draw something, we calculate how wide your data will take, but in this case we would set a specific width for your data. So basically our data unit or visible unit here is 1 day, so we would give 24 pixels per day. You could make it anything, but I chose 24 because 24 hours a day, so you get 1 pixel per hour. That sounds nice. And this X offset is the offset at which we start drawing values. So for example, if it is 0, then we start at the 0 of the X0 of the canvas. If it is negative value, we start drawing earlier. If it is positive value, then we will start after, and so on. So this is necessary for us to do the scrolling computations, but we will come to that later. So let's go into one other thing that we want to discuss over here or point out here is that the widget or the painter is wrapped inside a sized box. This gives a definite size for the canvas with 280, 640. You can't make it anything. So it's easier for us to compute stuff inside. So let's go into the custom paint chart painter, It's right here. Right, so there's a few things going on. We discussed earlier, as we discussed earlier. So we are sending in, or we are passing in the CRI object, pixels per day, and also the X offset. And then this, we can optimize the should repaint depending on how much performance you need. But for now, we would just return true, so it will always draw when it's called. And there's a bunch of paint definitions. We would need this to mark various things. For example, the markers, so the background color, the background paint, different paint, and the label box, BG paint, and so on. So these are things that we would use later on. One to note is that we give H padding as well as a V padding, which is horizontal and vertical padding. This could be different depending on what you want to, how you want to align your chart. For example, if you want larger horizontal padding and different vertical padding, then you can easily adjust this. So the first thing to do is to just draw the draw a rectangle in the canvas so that everything, you can see stuff. So we can do this by let me comment this out and then run it. Okay, so it gives a nice rectangle. There's nothing in it. The next thing to do is to draw some markers. So we'll ignore this. This is needed for when we want to scroll. We would come to this. Let's go into the function where we draw the markers. So this is where we compute the total number of days in the range between start and finish, right? And then iterate from 0 to number of days, and then we draw various things. We draw lines, we draw labels, we draw boxes and things like that. So first thing to do, we create full date rectangle. This would give us the region for each of the date. So let's comment this out, right? Okay, let's comment this out and then draw canvas, draw rect. That is the full date rect with some marker paint, let's say. Okay, so when we draw this, we see that boxes are drawn for each of the dates from start to finish. And then if we if you look at the end of this means that it continues on, but it is clipped because we'll use the clip R rect. So if we go over here and then remove this, remove widget, you'll see that it continues on, and then we can show that continues on, right? So we start from the 0 with some padding and then start drawing days from the start date here, end date somewhere on the right. Okay. Okay, put the clipping on so it clips in nicely. This is to show that the region each day would take, right? So let's go into the data rect, right? So data rect is used in here to draw the lines instead of boxes. So boxes, it's not very aesthetically pleasing, so we're gonna draw some lines instead, so it will look like this, right? And then we have enough space at the bottom to draw the labels for the dates, right? Okay, so that's what's happening over here. So let's go into the draw labels function. So what happens there is that it draws date values like this, right? So it has a bunch of variables, a bunch of parameters going in, but the most important part is that label rect. We compute the label rect, which is x1 bottom minus label height, which is x1 is this one, so the y is this part, and then x2 minus x1, which gives this box, so nice box like this. So we can show this box like that. So label box bg paint, let's make it style paint stroke, stroke width, something like this would be good. I can't type. All right, so let's have that. Color is indistinguishable from magic, so let's put some good color in there. Right, so this shows where we would actually draw these labels, right? Okay, so we're not going to have it in the final product, but this is just a, as you see, that this is a debug paint, but that gives us an idea where things are, right? So we're gonna get the date of each day we are drawing, and if it is the start of the month or the start of the week, we would use this function to come up with a nice short date. It's in this utility function, which is getting a data string and then some string magic to shorten the date and then print it nicely. It looks like that. We go back and then draw text. We'll draw the whole thing with a given style inside a given rectangle. I do deflate it because then it has some little border, little padding inside, and with some coloring. So that's what it does. Text left and all these text drawing functions, I use this all the time, and if you look at my earlier videos, you should be very familiar with this. It just measures the text and then paint the text with some alignment. Okay, we go back. So this would draw the labels. Let's take this out. All right. Most of these timelines or events that occur on a time series, we want to know when we display these things. We want to know, so we have to have some sort of a idea if a particular day is weekend or not, because the behavior of most things change during the weekdays as opposed to weekends. So what I do over here is that if we detect that the day is a weekday, or Saturday or Sunday, then we would draw it differently with a different background. So that's what's happening. Let's run this. As you can see, gives a nice shade, and now we have a good idea where things are, right? We know that 30th things are happening on 30th and 31st are on a weekend as opposed to the 1st of January. Okay, so we described drawing markers. Now what we need to do is to take a look at how we draw the data. Okay, so draw data function. It's again not that difficult. What we do is that we loop through each of the series and then get the events, right? And then go through each of the events and then draw them. That's basically what happens. So we just draw a circle for each of the events. But with some things that we have to note. This is a little guard so that we would not be divided by 0. So if the max value and min value is the same, this could happen when you have only one element in a series, right? Then when we compute this V ratio, max and min value will be the same, and then this would be divided by 0 and undefined. So we want to avoid that, so we just give 1 so that we just have something in there. Okay, so for each of the events we have a top V padding, because when we draw stuff we would draw inside this data area for each of the day, and then bottom is the size height minus the V padding minus the label box, so that things would just fit inside this box. Height is bottom minus top, and the V ratio is the height that we just computed, and the range of values, max minus min. So when we compute the X value, we want to have some idea of where it is starting. So the starting point would be somewhere here or somewhere, it depends on where you add the X offset, but it doesn't matter. What matters is that we get the series event. Actually we don't have to, since we have the events out here, we don't have to do this sort of like series events, just events is enough. Events date, difference between the start date, so we have the we start drawing markers from start date, so we take the difference in dates between difference in hours between the start date and the current events date, and then multiply that by pixels per day and then divide by 24, because we want pixels per hour. So that gives the X offset where this data point should land. And then we add some padding, and then this X offset is for scrolling around. The Y is the top, which we just computed, and then minus the so since we take the range between max and min values, when we draw this back, we want to get the difference between the value and the min value, and then multiply that by the V ratio we just computed, and then add this padding top. We take the value height minus, because the coordinate starts from 0 here and then go downwards, so we want to have things going bottom up rather than bottom down. That's why it is like this. And then we create a paint object which has the same color as the series that we are drawing. Fill it with, this is not needed, but anyway, and then we just draw a circle. So that's what's happening here. When we do that, the events are represented by dots. Green is a different series, blue is a different series, red is a different series. Since it is random, it doesn't show any kind of a pattern, but in real data you would see some pattern. This is the whole point of plotting time series data, to identify or visualize some sort of a pattern. But we can, if you want to have this sort of like realistic data, then we need a more sophisticated way of generating mock data. One thing I was trying earlier was trying to use Copilot to generate some mock data, but it was terrible. So one other thing that we can do is to create a simulation with an environment and a user, and then you have environment has whatever the thing that you want to model, and the user will have different properties, and then depending on the properties of the user or their behavior would be different, and they would make various decisions while they are in the environment, and these decisions will make actions. So the actions are what we record in this time series. With that, we would have more realistic looking data, but that's a completely different project. We can discuss that later on. But anyway, so now we have plotted these event data on a timeline. What we want to do next is to be able to scroll this around. Now with this does that because we have enabled the horizontal and vertical drag updates. So I will comment this out, then do that so that we have horizontal drag update, which will give us a delta value for x-axis, and we would store that in a x offset variable. So one thing that we need to do at a later stage when we want to prevent the user from dragging this edge away from the left axis, right? So this is the earliest event data. You don't want the user to drag it all the way here. It should the drag should finish when the user comes at this point. So usually the data would be somewhere here, and the user drags all the way to the first data point, then it should finish over here. So we would use that in a little while. So we go back to the width of data. This is where that happens. I will describe that in a bit, right? So let's take a look at how we are passing the x offset. So we want to have a way of persisting this x value, but it is also changed inside the paint object, as you see here. So if you pass in, if the passed in value over here, x offset would be was a primitive data type like double, then this would be passed by value, which means whatever you do inside this function or inside this object would not be reflected back to the caller. Because of that, we would use wrapper class, which would contain this value. Then when we pass this into a function or a class, this object is passed by reference. So whatever the changes that you do inside the chart painter will persist. So this is the reason why we have to use a wrapper class, right? Okay, so at this point what we just do is that we take the delta of the horizontal drag update and then add it to the dx value. It's called the dx value over here, and then pass this on. So in the function, when we paint stuff, we want to have a way of limiting the x offset to 0. So which means that we don't want the user to drag all the way out here. It should stop here, right? So that would happen if we do this. So as you can see, if the x offset is more than 0, then it would set to 0, so it would not, user would not be able to drag it further out. But you can drag this way. But on the other side, the same kind of problem, which don't want the user to drag it away from the right edge. It should be somewhere here. So we want to use the same sort of condition on the other side. So for that, you need to know something called the min x offset. To calculate that, we need to know the difference between the width of the data in pixels. So you get the width of the date range, start and finish in days, and then multiply that by pixels per day, which will give you the width of the data in pixels. And then a simple calculation, min offset would be size width minus the width of the. So in that case, what would happen is that we won't be able to drag the chart away from the right edge, but we can drag it all the way to the left, but also it prevents the user from dragging it out from the left side. So that's great. But one more thing that we want to add is a way for the user to fling this. So as you can see right now, if the user just stops dragging, the chart doesn't move. We want to make it more user friendly. So for that, we have another trick up our sleeves. That is when we use the horizontal drag end, because it has a velocity element. So luckily for us, the horizontal drag end gives us the velocity at which the user was dragging when it finishes. And then we get the x-axis or x velocity. We have a little guard over here to prevent the velocity from prevent us reacting to small changes, because user may be like, fiddling around, that you don't want the chart to move for everything. So we have a small threshold. For us to do this properly, we need to have a way of adding to the x offset, over here, after the user interaction has happened. So in order to do that, the only way or the easiest way is to use a timer, because we start a timer and then we invoke the timer at some sort of a frame rate over here. In this case, we use 60 FPS, so 1000 divided by 60 milliseconds. And then at every call, we would add the velocity with some scaling. We divide the velocity by 60 at that, and then we also scale down the velocity by 90%. We scale down by 10%, so the velocity would be 90%. This is to simulate some sort of friction. We have a timer, fling timer, and then we have this variable Vx, which holds the velocity value, and then we stop if the velocity absolute value is less than 0.1. One thing to note is that we should cancel the timer before we create a new one, because the user could be flinging this and then trying to interact with it again before the first interaction has finished. So with this, we should be able to fling this, for example, like that. Nicely smooth interaction. Okay, so that's it. That's this long video is all about. I hope that you learned something. If you like what I create, obviously like and subscribe. If you have any questions, just ask on the channel comment section. I'll try my best to answer these questions. Thanks for watching my videos. It means a lot to me, and catch you next time.